Hi again. Always near to the power jack you will find 19 volt, and the 19 volt will pass through a MOSFET or a switch or even two switches. Then will pass through a sense resistors or current sense resistors. And from this resistor, exactly like this resistor, the power will be divided into the whole motherboard. The power will be directed into every circuit in the motherboard. So in the motherboard you can find main circuit. For example, as you can see, the charge IC circuit. Okay, this circuit you will find it always near to the power jack or near to the battery connector. Also the 3.3 volt and the 5 volt circuit. Okay, you will find also the CPU circuit. Okay, and also the GMCH and ICH circuits and also the RAM circuits. So you can determine the circuit by the coils. Always when you find one coil or two coil with capacitor and MOSFETs means this is a circuit. Okay, so for example, for the CPU, as you see, so we have here, as you see, a coil, and we have MOSFETs over here, and we have capacitor, as you can see. Okay, we have also another coil with capacitors and two MOSFETs and in the other side. Okay, so the same, for example, here. So here, as you can see, for 3.3 volt and 5 volt, as you can see, this is, as you can see, coil with this capacitor and MOSFETs. Also here we have coil with capacitor and MOSFETs. Okay, so I will show you another motherboard. So for this motherboard, as you can see, okay, also here, as you see, so here we have coil, we have MOSFETs, we have capacitors, as you can see. Here we have another coil, MOSFETs, capacitor. You can find this capacitor. This is chemical capacitor, and also this is a chemical or polarized capacitor. Okay, and here, as you can see, for the RAM, so we have coil, we have chemical capacitor, and we have two MOSFETs, as you can see. Okay, for the processor, as you can see, we have coils. So the processor can contain many channels, not just one channel, but many channels. Okay, also here, as you can see, okay, we have here coil, MOSFET and capacitor. So I will show you another motherboard, a last motherboard over here, as you can see. So we have coils, as you can see, we have here coils, we have, as you see, this is MOSFET, here we have capacitor, also coil, MOSFET, capacitor, coil, MOSFET, capacitor. Okay, and here we have the power management IC. Okay, so let's see here, for example, we have coil and capacitor, here also coil, capacitor. Okay, coil, we have, this is a MOSFET, this is another kind of MOSFET, as you can see. Here also coil, MOSFET, this is third channel for this CPU. Okay, as you can see here also, for the graphic card, we have coil, we have capacitors, we have MOSFET. Okay, so in every motherboard, so if you understand just the process of repairing in one motherboard, you can understand any motherboard, any laptop motherboard. Okay, now I will show you in a paper the main schematic of every circuit. In every circuit you will find some component. So let's get started. So in every circuit in the motherboard you will find a power management IC. Okay, so let's assume that this is the power management IC. Okay, this is the power, okay, management IC. This IC can be the charge IC, the 3 volt, 5 volt IC, the CPU IC, the GMCH IC or controller. We can see power management IC or power management controller. So this IC is responsible to generate a specific voltage for a specific component. For example, if we speak about the CPU, for example, let's assume that we have here the CPU, for example. So this IC is responsible to generate the voltage for the CPU. So for the CPU always needs a voltage that we call VCC core. Okay? The voltage for the CPU is VCC core, about 0.8 volt to 1.2 volt or 3 volts in accordance with the CPU. So this IC is the responsible to generate this voltage. But this IC itself cannot generate this voltage. It needs some components. This component is MOSFETs. Let's assume that we have here MOSFETs. So at least 2 MOSFETs. Okay, so this is the high MOSFET and the low MOSFET. So let's assume that here we have the drain of this MOSFET, here we have source, okay, and here we have gate. We have another MOSFET with, for example, drain here, okay, and source here and gate here. So the gate of each MOSFET will be connected to the power management IC, because this is the controller. The controller of this MOSFET is this IC. This MOSFET is exactly like a switch. And here we have on off. This IC controls this MOSFET and this MOSFET via the gate. Okay, so here this is the gate. Okay, here this is the gate. Okay, so this MOSFET is the higher one. So here we have drive. We can see here this is the drive high signal, and here this is the drive low signal. Okay, so this MOSFET, the first MOSFET, always should be connected to the main power. Let's assume that this is the V adapter. Okay, the V adapter about 19 volt, for example. So always the 19 volt will be applied to this MOSFET, but through some filtering capacitor. This filtering capacitor can be 1 or 2 or even 3. Okay, and these capacitors are ceramic capacitors. Okay, so also this 19 volt or the main power will be also applied to the IC itself. Okay, because the working voltage for the IC is the same voltage as the voltage that is applied to the MOSFET. So here we have 19 volt. This is Vn. Okay, so this 19 volt will be applied here, but will stop here because this MOSFET is not yet activated, and the source of this MOSFET will be connected to the drain of this MOSFET, of the second MOSFET. And then, in order to protect the CPU, this MOSFET should be connected to the ground. Okay? So, after that, we need the connection between this combination or this circuit that contain power management IC and two MOSFETs and the CPU. The connection will be here. So this voltage that we will get here between these two MOSFETs will be applied to some chemical capacitors. As you see, we have here plus. This is a polarized capacitor. Let's assume that we have just one polarized capacitor. This is a filtering capacitor. And then through a coil. Okay, so this is L, for example, L1. And then we will get the VCCP or the VCC core. So here, this is just one channel. For the CPU, you can find another channel, the same channel, another channel with same component. Okay, you can find, for example, another channel here. This is the first channel. Okay, so this is the channel 1, and here, for example, the channel 2. You can also find another channel. Okay, so for example, the channel 3. Every channel contains the same component, and every channel generate VCC core, the same VCC core. The purpose here of these channels in the CPU is to release the heat. Okay, is to release the heat of the power management and of the MOSFETs. So because the CPU is always in work, it works always. As well as you press the power button of the computer, the CPU starts working until you shut down the computers. That's why it should be powered in every second. That's why if the CPU is powered just via one channel, the heat of this IC and this MOSFET can be increased. So to release the heat of these ICs, we have here many channels. This, for example, can work for 3 seconds. This also for other 3 seconds. This for other 3 seconds. Or this 10 seconds. This will work 10 seconds. This will work 10 seconds. Okay? So this is the main principle. In every circuit in the motherboard, you can find this process. Okay, I will show you, for example, to generate, for example, 3 volts. To generate, for example, 3 volts, you need a power management IC. Okay, so you need 2 MOSFETs, as you see. These MOSFETs will be controlled via this IC. In its gate, this is the MOSFET number 1, this is the MOSFET number 2, Q1, Q2. So the source of this MOSFET will be connected to the drain of this MOSFET. The source of this MOSFET should be and have to be connected to the ground in order to protect other stages or other circuits. Here we need 3 volts. Okay, here we need 3 volts. So this MOSFET, okay, should be receive 19 volts. Okay, 19 volts, and this 19 volts should be passed through some ceramic capacitor. This is filtering capacitor. So here we need a chemical capacitor, or a chemical capacitor or polarized capacitor. Okay, and then a coil. All this is a filtering compound. These two will filter the signal in order to obtain a pure signal. Okay, so this IC should be powered by 19 volts, so the same power. Okay, and of course we have here ground and some enable signals. For example, enable 3 volt in order to have 3 volt, and many other signals like shutdown signal, for example, etc. So in every motherboard, this is the schematic of every circuit in the motherboard. All circuits in the motherboard has the same purpose, is to generate a final voltage via many components. This component always is the power management IC, MOSFETs, capacitors, chemical capacitors, inductors, okay, and also ceramic capacitors